my friends, good morning. In this video I'm going to show you that 8 plus 1 over 9 is lesser than square root of 66, and it is lesser than 8 plus 1 over 8. And to show you this, I'm going to apply to a theorem. It is the Theorem of Lagrange. And so, first of all, I'm going to explain you a little bit about this theorem. So let us say that f is a function, is a real function which variable is also real, and this function is continuous at the, let us say, interval a, b, a closed interval. It is continuous here, continuous, and it is differentiable in the open interval a, b. It is differentiable also. Differentiable. So, in these conditions, I can say that there is, let us say, C, which belongs to the open interval a, b, which the derivative of f, let us say f prime of c, it's equals to f b minus f b over b minus a. So my difficulty is to find a function which requires to demonstrate this theorem, and because of the presence of the square root of 66, I'm going to apply to this one function f of x equals square root of x, and I'm going to draw a graph, a little picture where I show you the graph of this function. Let us say the graph. It is not very difficult to draw. It is something like this. Which domain? It is the set of the reals, positive reals, including the zero and also the image, as you can see. This function is all time increasing, as you can see. So applying to the theorem, and because of the presence here of square root of 66, I'm going to choose this interval. Of course, I'm going to choose this closed interval, 64 to 66, because if you can see, it appears here 8 and 8 squared, it is equals 64. I think it is not difficult to understand this. So in these conditions, I can say, as you can see also, I don't remember if I told you about this, that square root of x, it is continuous in this interval. It is also differentiable in this open interval. It is all time increasing. So I can say that there is a, let's say, C, which belongs to the open interval 64, 66, which the derivative of C, it's equal f of 66, let's say square root of 66, minus square root of 64 over 66 minus 64. And now I must find the derivative f of x. I think it is very easy to find, because the derivative square root of x, it's equals to the derivative of x, it is 1, as I think you know, over 2 times square root of x. But I want this derivative in the point x equals c. So let us say it is 1 over 2 square root of c. Okay? So if I take this equality over here, I think it is very simple to understand that square root of 66 minus square root of 64 over 2, because 66 minus 64, it's equals to 1 over 2 square root of c. Okay, it is very nice. And then now I'm going to explicit this part of this equality. Okay, so it is not difficult to do this, because as you can see, square root of 66 minus square root of 64, it's equals 2 over 2 square root of c. But now I can cancel these numbers 2 and 2, because it is products, and I can cancel. I have no problems with this. And I know also that c belongs to, it's lesser, let us say lesser than 66, and it is greater than 64. Then the square root of c is lesser than square root of 66, and it is greater than the square root of 64. Then the inverse, if I take the inverse, it is simple to understand that 1 over square root of c, it's lesser than 1 over square root of 64, and it is lesser, but it is greater than 1 over square root of 66. Okay, so now I have all to continue my demonstration, because if I apply to this value over here, this number over here, I know that this number, it is between these two other numbers, and this number, it's equals to this difference. I can write this very easy to understand. I think square root of 66 minus square root of 64 is lesser than 1 over 8, and it is because 1 over 8, because square root of 64, it is 8, and it is greater than 1 over square root of 66. But if you can see, square root of 66, it is not an exact number, so I must find it to show to you this double inequality. So the next number very close to 66, it must be, let us say, 81, and I can write here 1 over square root of 81. Okay, so from now on I'm going to apply to the transitivity of it is a property of the inequality, and easily I can find that the square root of 66 minus square root of 64, it is lesser than 1 over 8, and it is greater than 1 over square root of 81, which is the same as to have 1 over 9. Okay, that's good, because now I can put this number to this side of the inequality, and also to this side of the inequality. So it is quite simple to understand that I will have 1 over 9 plus square root of 64. It is lesser than square root of 66, and it is lesser, this one, than square root of 64 plus 1 over 8. Let us say that square root of 66, it is lesser than 8 plus 1 over 8, and it is greater than 8 plus 1 over 9. Okay, that's good, because now I did show you that this can be, and I did show you this double inequality applying to the Lagrange theorem. I hope that you did enjoy this video and have a very nice day.